Hi, this is Diane. You're currently watching the Just Kidding Around show. Thank you so much for joining us. Each week we introduce our home viewers to different artisans in our community. And this week we are re-welcoming Jeff Evans. Hi, Jeff.
Thanks for having me back.
Yeah, do you consider yourself an artisan?
Well, if I get this is going to be third time's a charm.
So Jeff is a magician in our community, and he's in a lot of communities because I know you work in Seattle and all of Thurston County. And
put a lot of miles on the car, for sure.
A lot of miles on the car. So you do a lot in Washington State, right?
I do, yep.
Yeah.
And outside the state, too.
Outside the state? Well, anyway, so if you recognize Jeff, you might have seen him on some big major events. Anyway, and it's the third time you've been on the show.
That's right.
I know. One of the things I remember most was this, we picked up ice, or we put, like, ice cubes.
That's the Ice Cube Rescue.
Yeah, Ice Cube Rescue. Yeah,
yep, you need a piece of string, some salt, a glass of cold water.
So you always do something fun. Seem to always have dry ice on hand, too.
Yes, and that leads right into our first trick, which is everything today, they're all science stunts that you can do at your house.
Okay.
Well, almost all of them, but not when your mom and dad are there.
So you're going to teach the kids how to do it?
Some of them. Now, to get dry ice, you need to be a grown-up to buy dry ice.
Is that right?
Yeah.
Where do you buy dry ice?
You can get it at some Safeways.
Really? Grocery stores?
Some Walmarts,
Okay.
some Wincos.
Okay, so
but not all of
basically
them.
grocery stores or...
Yep, check them out.
Grocery stores, all right.
So this is a bottle with a bunch of small pieces of dry ice in the bottom and some hot water. And by the way, dry ice, if you're not familiar with it, is super cold. It's 109 degrees below zero. So it's carbon dioxide that's super, super cold. And when you handle dry ice, you want to wear gloves so you don't freeze your fingers. I also have...
You don't say, here, catch.
No, no, no.
Okay.
So what's going to happen is when I pour the hot water into the dry ice, and I wish I could show you some.
Ice, nothing else.
Yeah, nothing else right now. It's going to change from a solid back into a gas. And scientists call this sublimation. So it's going to sublimate, going from a solid back into a gas, and it's going to look very sciencey. I'm going to stand up here. Now here's your job. You're
I've got to do something?
Yeah, you just hold on to that.
Watch.
This is how we're going to make the dry ice bubbles. And by the way, I learned this on YouTube, so you can find amazing science stuff on YouTube also. All you have to do is...
Are you on YouTube?
I am.
All
yep, you
right.
can just search for Jeff Evans Magic.
Cool, Jeff Evans Magic. Whoa. What am I doing here?
Okay, so just dip that into the bubble solution and then lift it up. Go ahead and get another one. And then lift it up.
Oh! Do I put it back down? Oh, we're making bubbles.
Nice. Now this time, lower the bubble onto the tablecloth.
All right, may I move this?
Yeah, absolutely.
Oh, we're making little clouds?
Sometimes they'll stick. Sometimes they don't pop.
Do we want them? Okay, so my goal is to not have it pop.
Yeah.
Okay, let's try it again. And what's in the solution I'm dipping in?
It's Dawn dishwashing soap.
Oh, it could be any dishwashing
Yep.
soap. So it's just water and dishwashing soap. So I want this to sit there. I'm going to put it down a little. Oh, darn it, I almost had it.
Ah, there, you see that?
Oh, look at that.
Ooh, there's little,
some of
little
them
dry
are
spell. Oh, look at that!
Oh, those are staying real well. Okay, now I want to redo it.
Okay, okay.
So that's a cool close-up somebody had there on the bottle. Okay, so I'm just squeezing. Ooh, see, I got a big one that
In fact,
Oh, how fun. So how do you explain this, or are you going to explain it?
Well, it's just bubbles that are filled with dry ice so you can see them.
So do you like science more or magic more?
Oh, I love magic more. But, you know,
But isn't magic all science?
it is
Pretty
very
much?
much. Very much. Yep.
Sometimes optical illusions or something? Oops.
Give me a little more time.
The kids and I have been learning about Houdini.
Ah,
It's been fun at South Bay Elementary.
he's got a great biography.
Yeah, we've been working with encyclopedias and internet. Oh boy, those are sitting up.
Ooh.
But he was like
Here,
an extreme
try and hold it up.
artist.
I'm going to try and see if
Okay,
I
you
can
want me
touch
to just
one in my
hold
hand.
it now?
Yeah. Nope.
Okay, let's try.
Sometimes you can catch them. All right, well, that's cool. That's cool. Let's move on.
How fun. I could do that all day.
Yeah.
Well, thank you.
You bet. So now I want you to pick up the white, it looks like a ping pong ball, and you'll notice that there are two little metal connections on it. And just go ahead and touch the two metal connections. It's not going to shock you or anything. Aha. So this is a demonstration of
my nose?
conductors and insulators. And basically, when you touch those two, maybe we can get a close-up of this if you hold it, but turn it around so they can see the little connectors.
Oh, there you go.
Yeah.
Close up. Close up of the connectors, maybe?
So what's happening is the electricity, your body is completing the circuit.
Oh, what a fun thing to do at a science fair. So when I touch those, am I covering one of them or something? Oh, I know what it is. There they are. Now they're showing.
As long as you have a
when I
little bit of
touch
moisture
them-
on your fingers. If your hands are really dry, then they won't do that.
I shouldn't look in the... If my hands are dry, it won't do it. Would this be a great science fair project?
Well, this would be a fun thing to maybe experiment with and get other people. You can actually have a chain of people holding hands and see how many people you can get to complete the circuit.
Oh. So when a teacher's teaching
Yes.
circuitry,
Yeah.
how fun.
Yep.
Yeah.
And actually, that goes with everything on the table. But before we get to that,
All right.
we have to do some chemistry.
Okay.
And I still
I'm
remember
excited.
the first day of high school chemistry class, Mr. Cummins had a paper towel, nothing on it, and a clear bottle of some kind of liquid, held the paper towel up and squirted it, and as the water or whatever chemical it was touched the paper towel, 3 words appeared. It said, "Chem is try."
Oh.
And I've remembered that for, over 20 years. So
Oh my
it's true that when you
goodness.
see amazing demonstrations,
I wonder
it really
if he's
can.
out there watching this show.
I don't know. I
Look
saw
at
him a
that.
few years back.
He-
So here's
wow.
a little bit of chemistry. I have three
Okay.
containers, and each one has a different material in it. This, I'll see if take a smell of that and see if you can
No
guess what
sip.
it is.
That's vinegar.
That's vinegar. Yep.
Whew. Red vinegar.
It's apple cider vinegar.
Oh, apple cider. Bleach.
Yes.
Don't get that near my
Yeah.
clothes. I'm terrible with bleach. I
This
get it
one will
on-
be the
Is this going to be
a
better?
little better. A little better. Or no, it'll remind you of something else.
It's not water?
No.
Oh, ammonia.
Ammonia. Yep.
Well, I couldn't feel it at first, and then, whoa, ammonia.
And this is the liquid that you get after you boil red cabbage.
You're kidding me, and it's purple?
Yeah, it's purple, reddish purplish.
Oh, wow.
And what most people don't know is that this makes an excellent litmus test. You know, litmus paper, in fact, I brought a little container. Usually it's a little strip and you, maybe you did it in school where you'll like chew on saltine crackers and then you'll,
Get your pH?
yeah,
thing?
exactly. And it changes, becomes different colors. But in this case, the liquid is going to be our litmus indicator. And when you put red cabbage juice into that was the vinegar.
That was
the
the vinegar.
It turns pink, and in the bleach,
It's going to turn, oh.
turns clear, and in the ammonia,
It turns
turns
blue.
blue-greenish, yeah.
Wow.
So that's a little bit of chemistry magic without using any food coloring.
No food coloring at all. And we got our purple here, too.
Yeah. You know, can I get one of our one of our camera operators maybe to come and give me a hand.
Don't
getting rid
spill
of this. Yeah, awesome.
Look at that, red, white, and blue.
Thank you very much. Now, onto this electronic circuit, because I actually got my start in science through electronics. Thank you.
So you're interested in electricity?
Yeah, I was really interested in CBs as a kid and then in ham radio in high school. And when you get your ham radio license, you need to take a test that includes basic electronics like calculating the resistance of a circuit or the power of a circuit.
Wow.
So I learned that, and then in high school I took an electronics course, then I went to Newmarket Vocational Skills Center and did their electronics. So this is an electronic project built onto paper. And the weird thing about this is they now have pens that have conductive ink. So rather than using wires, I use this pen to wire this circuit. I've also
You're
put together
kidding.
a little diagram. Whoops.
Oh.
So if you direct your attention to the TV, let me speed this.
Just
So,
like cabbage. Oh,
Right.
that's what we just did.
so in vinegar it turns pink,
Classy here.
green in bases, and colorless in bleach. Okay, so this is what the circuit looks like, and this is called a schematic. Just maybe turn this way.
Oh, that's kind of nice. So they can be looking at that while we're doing our little...
Right, so the four parts, the four components in this circuit are the battery, which you see at the left, and the electricity will flow from the battery through the resistor. The resistor limits the amount of current, and then it goes to the LED, and that's the light bulb, and then it goes around to the switch, and then back to the other side of the battery. This is a multimeter, and with a meter you can measure a lot of different things like voltage, current, resistance. You can check components to see if they're working properly, check continuity to see if there's a short, and sometimes you want shorts and sometimes you don't. And this is me checking a resistor before I put it in the circuit. And now that is what it looks like when I'm putting the conductive ink onto the paper. And this is the final project. So if you want to shift back here, we'll see how this is working.
So that all led up to this.
Yeah, exactly.
Okay.
So the electricity is going to flow through the battery, through the resistor. Without the resistor, the LED would probably burn really bright and then burn out. And then this is the switch, so I'll let you go and flip that on.
Put that on here.
Oh, sorry, there's a little switch right there.
Oh, flip it.
Yeah.
That one. Oh,
Okay, there.
my goodness.
So this is the most basic kind of circuit. It's called a series circuit.
People can't use that in a professional way, can they? For circuitry? Like
You
in
could.
a house or something?
Wow,
This?
not in a house.
Just for an experiment.
Just for small
projects.
DC
Like
type,
craft
not AC.
kind of things.
Yeah.
Okay. Wow. And may I touch this?
Absolutely, yep. Yeah, it goes on kind of like a
it's
gel.
thick. It's like a gel.
It is thick.
So it feels, but there's no wire in there?
Nope. And interestingly, when you first put it on, it doesn't conduct electricity, and then as it dries, then it becomes conductive.
That is so amazing. Can we hold up a little?
Yeah.
We have to show this to Jerry Julian. Can you use it like for making a model boat or model train or something?
You
Can you think
could.
of uses
I mean,
for this?
honestly, if you're doing a more permanent type project, I think that wires are the way to go.
Oh.
But this is pretty neat, and you could have it wearable. You can put it on fabric.
Oh, that would be a use.
Yeah.
Wow. How fun. I bet you could use that as a magician a lot. Or glowing, whatever.
Well, you know, there's a lot of technology that magicians will use, and sometimes cutting-edge technology or technology that you wouldn't expect would be used in magic trick that over the years magicians have used.
Yeah.
Like there's a story about in the old days when electromagnets were new, a magician had a huge electromagnet installed in the bottom of his stage with the metal plate in a box. And the idea is that he'd have a small child come on and lift a box, which he could do, and then the strongest guy in the theater would come up, and the magician would apparently hypnotize this man so that he would be unable to lift the box. But off stage, his assistant was throwing the switch and energizing the electromagnet so that the man could not lift the box. But now we're going to do some math-a-magic, because there's magic in numbers. You've got a big pad of paper there. Go and pull that over. And I would like you, let's turn it this way. I want you to think of a huge number, not like your lucky number, which might be 1 or 2 digits, but take one of the pens, and I want you to think of a number that has not bigger than hundreds, bigger than thousands, bigger than tens or hundreds of thousands. I want you to think of a number that's in the millions. So at least,
Should I write it down?
at least 7 digits, or 8 digits, even 9 if you want. I want you to write it
digits?
right about there. Leave some space because we're going to be adding up some numbers.
Right now?
Yep. And it's okay if I see
you
it.
gonna watch it?
It's not one where I try and guess what you're writing, but I am going to make my own prediction based on the number that you jot down. So you put down a number, and I'm going to make a secret prediction on this pad of paper. And make all the numbers random. Don't use like 50 million. Make it.
Is that okay?
That's a huge number.
Do you want me to take the last 3 off?
Nope, that's fine. I'm making. Oh my gosh.
I can take the last 3
Okay,
off.
I'm going to set my prediction right over there. Okay, so that is a big number. Now I want you to put another number, the same number of digits, but a totally different number, right underneath it, and try and make it so the numbers will line up, because in a minute we're going to add some things up.
So then, oh, okay. So the numbers will physically line up.
Yes. So for those of you watching at home, in a moment, hopefully, my prediction is going to add these totally random numbers
Oh,
that
come
even you
on.
did not know you would be writing at this moment. So that number is at 1,321,143,553. And there's no way that I could have known that you were going to come up with that, because I don't think you knew it a moment ago.
I didn't know it.
Let me see this. I'm going to
I had a
add.
hard time coming up with it.
Let's randomize this even more. I'm going to add. Just going to put some numbers down here. See what
This
happens.
is more about math than science, I think, right? This one?
Okay. I like 8 billion is a good number for me. Now, you get the hard job. I want you to add up
Oh,
these
come on.
3 columns.
All the way across?
Yes, I'll be
Okay.
watching to help you out.
I'm sorry. Wait a minute. I would have made it a lot smaller if I knew.
No, this is what makes it so impossible, because this is outrageous. Wow. Okay, so add the commas in so we really see what.
So it'd probably be
19 billion. That is I've been doing this a long time, and I think that is probably the biggest number that's ever randomly been created.
So this is our math
Actually,
problem.
okay.
There's our math problem. I don't know which camera to show it. Does that show up? Okay, he made me add that up.
So let's kind of recap. At the very beginning, I made a prediction that's been sitting down on the table right here.
Yeah.
Now, we ended up with 19 billion. If I was within a couple billion, that would be pretty amazing.
Because originally you told me to do million. You didn't even tell me to do billion.
Right, and then you kept adding digits. So let's see if I came with, even close to.
Oh, come on.
Now, why don't you turn yours around so this camera can get it?
Oh,
We'll see. I had this. This can't be happening. Yeah, turn around. So 19 billion 765 million
Assuming I added
367,126.
Identical.
Wow.
Is it identical?
What are the chances?
Oh, come on.
That was a coincidence.
What?
Okay, so let's go over how this works.
What? You must have been adding that while I was adding this. Were you over there adding?
No, I didn't have a midget under the table.
It was
doing anything.
upside down.
So let's do this. I'm going to circle something that you're going to see. I want you to look. Yeah, this number here.
All right.
And this number here. 976536712. Wow, that's really close. In fact, a lot of the numbers are exactly the same.
Why?
Well, here's the next thing I want to call your attention to. Check this out. 8 and 1.
Yeah.
Oh, maybe if we can lift it up just a little bit more.
I'm sorry.
So 8 plus 1 is 9.
Right.
6 plus 3 is 9. 7 plus 2 is 9. 8 plus 1 is 9.
So the number you put down
basically
was the trick.
Yes. Basically, I'm going to add 9999999 to whatever number you wrote down first.
Oh.
And the way, the magic behind it is that when you add 99999 to anything, it automatically adds a 1 to the front and subtracts the last digit by 1. So when I saw you put down your first number, my prediction is I put a 1 in front, I copy all of your digits, however many exactly, until I get to the last digit, and then I subtract 1 from it. So your last digit was 7, so my last digit became 6.
Okay.
Yeah. So now
I
that
did
you know
notice
it,
I was consistently carrying 1. It did seem kind of odd. I kept carrying 1.
do you want to try one on your own?
No, that's okay.
Okay, all right.
I believe you.
So try it, and
After the cameras are off, then I'll try one of my own.
the neat thing is
Oh, that's interesting. That is the same number, isn't it?
this is something you can do
This
anywhere.
added 9999. Got it. Okay. Man, you're a pretty crafty guy. So you're saying science? I mean, magic involves science, math,
Occasionally.
chemistry.
Chemistry?
A lot of different
Sometimes.
Well, chemistry is science, but I don't think of math as so much. That's interesting.
And the great thing about this, you can do this at a restaurant on a napkin. In fact, I learned this from a guy after one of my shows who took me over and just showed me this.
So, but you must have been writing, you wrote that number down as I was writing this number then.
Yes, I have to know what your number is first.
Yeah.
But hey, let's move on. Do we only have
Still
5
pretty
minutes
well
left?
until you told me how to do it.
Okay, time flies when you're having fun.
That doesn't, 5 minutes left? That doesn't seem right.
We need to experiment in gravity.
Okay.
And right inside of my pocket is something that will probably look familiar. Do you know what that is?
It's a purse.
It's my magician's wallet, so hold on to that. So gravity obviously happens when things are falling towards the earth.
Okay.
But think about this. Is the earth flat like a map, or is it round like a ball?
It would be round like a ball.
Round like a ball. So if you were in Australia, in the southern hemisphere, the land down under, and you drop something, would it fall down or would it fall up? Hey, it falls down. They're not walking upside down in Australia. But since the mass of the earth is so great, that's what creates gravity. That's what makes things fall towards the center of the earth. But I've discovered a way to slow gravity down. And to demonstrate, I want you to take a quick look at that. I also have a tube. It's an aluminum tube with holes drilled in it. And now I want you to hold that. And we're going to do this in slow motion. Slowly drop the cylinder in the top of the tube.
Slowly?
Well,
that was pretty slow.
yeah, do it again, do it again.
That's
And this
pretty
time,
slow.
you can actually see it as it falls.
Oh.
So this is based on eddy currents. When you pass a powerful magnet through an aluminum or especially a copper tube, it creates an eddy current that it creates a magnetic field that's opposite to the magnet that's actually falling down. So there's two magnetic forces, and the magnetic fields are attracted, so it slows down the speed at which it falls. And I just happen to bring a giant copper tube. So go ahead and stand up, because I want you to experience this. I want you to hold that, and you're going to take this, you're going to drop it in the top,
Yeah.
and kind of hold it up off the table just so you can see, look down and see it, watch what happens as it falls. So look in the top of the tube.
Wow. It's spinning.
It's actually tumbling almost as though
not
it's
spinning,
weightless
right.
in outer space.
It's end over end. Wow, that looks cool. That looks neat.
Yeah.
It doesn't drop straight down.
Well, it does. It does drop straight down.
It is dropping straight down?
It's dropping straight down.
Why does it look like it's...
Well, you're kind of tilting the
Oh.
tube.
Well, you told me to look.
All right, so we need to do, oh, actually, here's a quick gift for everyone at home. It's a little bit of science that they can do at their own house. On my website, I have activity sheets that kids can do. So if you go online to edgeamazement.com, you can download your own levitating magician that'll float on the end of your finger.
Whoa.
And an activity sheet with more stuff you can do at the house. But for the grand finale, I wanted to go out with a bang. So put those on. Safety first.
I can't believe the show's over. I feel like we should be starting, Jeff.
So this is a piezo popper, just like you might find on your gas fireplace. There's a little spark there. And I've got some
I see that.
flammable hairspray.
Flammable?
Yep. I'm just going to hold it in my hand to heat it up for a second.
All right.
And I want you, when you're ready, oh, did you want to say goodbye to everyone first?
Goodbye. I better say goodbye. It's been nice knowing you. Goodbye to the kids at South Bay and Lydia Hawk, because when I push this button, I don't know what's going to happen.
When you're ready, go ahead and hit
So
it.
I'm going to say tune in again for the Just Kidding Around show. Bye. I'm going to push the button now. Oh.
Try it.
Oh, gosh. Wow, how did all that come out of this? Now, that was really amazing. How'd you ever get all that in there? You're amazing,
It's magic.
Jeff. So, that's a wrap. Thank you for joining us. Tune in again sometime for the Just Kidding Around show. Thank you, Jeff Evans. And will the kids see you around?
Hey, I'm always around.
Thanks to Tom Dubuque, Jerry Jillian. Thanks to Jim Elder.
It's playing.